let us say, so let me limit again the scope of it. So using a 0 is there, 0, 1, 2, 3, 4 and a 5. From 4-digit number, that is divisible by 4. So what this example introduces is that conditions need not always be even, odd, greater than 3000 or so on. I could have a different condition also, like divisible by 4. Divisibility by 4 is the last 2 digits should be divisible by 4. Right? And so let's treat the last 2 digits as one packet itself. Right? What can be the possible, how can we fill these positions in so that is divisible by 4? Quite a few students try a hit and trial. Okay, it could be 20, it could be 24, it could be 32 or so on. However, there is a possibility that you might miss something up. So take a moment, pause the video and write down all the different possibilities and see whether you have counted all of them or not. Once you have done that, you will realize it's much better to go in a methodical way rather than randomly out way. What is a methodical way? Take multiples of 4 turn by turn and check whether they can be filled in here. For example, I am saying the positions could either be filled with a 0, 4, the first multiple. 0, 8, I do not have this. Third multiple, 12. Can I fill in with a 12? Yes. I'm just writing it separately here. In a moment we'll realize why. So the last 2 positions could be 12, 16. Oh, I don't have a 6. 20. Yes, there is a 20. A 24. Yes, 24 could be possible. 28. No. 32. Yes, 32 could be possible. 36. I don't have a 6. 40. Yes, a 40 is possible. 44, I cannot repeat digits. If I miss that out, this question is again without repetitions. Right? 40, 44, I could not form. 48, there's no 8. 52, yes, there's a 52. And 56, there's no 6. 60, now we have reached 60. Multiples greater than 60 will definitely have a 6, 7 or an 8. We do not have. So I'll have to take a pause. Now why have I written it in separate columns? These include a 0. Whereas the other ones include a 0. These don't. And it does matter. So for example, if these are your zeros, having filled this position in, out of the 6 available digits, 2 have been used up, right? And I am left with 4 of them. So the other positions could be filled. So this is how many ways? This is just 3 ways. And the other positions could be filled in with a 4 into 3 ways further. So 4 3s are 12, 12 3s are 36. There could be 36 such numbers. Let's write this somewhere. 36 such numbers are there. So let me just put it down out over here. 36 numbers which have a 0. However, instead of this, if the last 2 digits were any of these, 12, 24, 32 or 42, it could be filled in 4 ways. Having filled this in, 2 digits have been used up. That could be 4 into 3 ways to fill in the other 2 positions. So total possible numbers, 4 3s are 12, 12 4s are 48. Right? And either the first set of digits could be the last 2 digits or the second set, and hence the answer is going to be this plus 32 plus a 48. And so answer becomes 70, that is an 84. So 84 is the answer out over here. Hope you get the idea. Conditions, there could be many such conditions that could come in. And keep a watch out for 0 as well out over there. You could even allow a 0 to come in the first position and that continue. I'll leave that working to you and see that you should get 84 as the answer itself in that case. There is one unique question. So we'll end the topic of forming numbers with that unique question. That unique question is, let's say using 1, 2, 3 and 4, find the sum of all possible numbers, all possible 4-digit numbers. And this time I'm mentioning without repetition, without forgetting it. So this time this question is different because it is asking us the sum. And it's not asking us how many numbers can we form. What is the sum of them? We know how many numbers can be formed. So let's just do that work. So if there are 4 positions, there's no condition, there's no 0 out over there. So the number of ways they could be filled in is straight 4 into 3 into 2 into 1. That is 24 such numbers. So I'm just making a sort of a list of 24 numbers. So there are 24 numbers and so on. And I need to add all of them. So after adding them, what is the possible sum? Let's go by a very garden variety addition. Start with the units, let's see, and add all these positions. So which numbers do we think are we going to encounter out while adding them? Would I have the digit 1 in the units place? Pretty much. How many times? So let's see. I am looking for numbers such that 1 is in the units place. How many such numbers can be formed? These could be filled in with 3 positions, 3 digits, so 3 into 2 into 1, that is 6 ways. So there are going to be 6 positions which have the digit 1 in them. So when I add them 1 plus 1 plus 1 plus 1 6 times is nothing but 6 into 1. Now is this particular about 1? Could there be certain numbers which have the digit 2 over there? And tell me how many numbers will have the digit 2? Is it still going to be the same? Now I'm left with 3 other digits and 3 positions. And could I also have a 3 out over here as well as a 4? And I would have each of this digit occurring 6 times. Does that add up to all these 24? So let's see. These are 24 different numbers we see. These 24 numbers can be separated out into 6 numbers of the type 1. So there are 6 such numbers. There are going to be 6 numbers which have the digit 2 in them and the units position. And similarly, it would continue, and that accounts for all the 24 possible numbers. So let's see the addition. Is the addition, instead of adding them, is it same as 6 times 1 plus 2 plus 3 plus 4? Right? And this is going to be 10, 10 6 are 60. Okay, so we have added the units column and the addition is a 60. So now let's come to the tens column. How will the tens column look like? When I go to add the tens column, would I again encounter the same digits 1, 2, 3 and 4? How many times will I encounter the digit 1 in the tens place now? Okay, so 1 is filled in the tens place. I am still left with 3 positions and 3 different digits, and so they could be filled in 3 into 2 into 1 ways. That is 6 ways again. So I would again be having 6 numbers which have the digit 1 in the tens place. The same logic will go with 6 numbers which will have the digit 2, and it is obvious there's a lot of symmetry out over there. Each digit can come in every position equal number of times. So there would be 6 numbers in the having 3 in the tens place, 6 numbers having 4 in the tens place. Oh, that means it will look, the addition will be same as 60 again. 60 and a 6, 66. Hundreds position will also be similar, so 60 and a 6 is 66. Thousands position will also add up to 60, and a 6 carry forward, which is 66,660. Do I have to do it this way? Not really. Could I just generalize this? Yes. How could we generalize this? Okay, let's see. the units column has a value of, let's say, 60, and since it is in the units position, tens column will also have an addition of 60, but this time the value that it is adding to the number will be 10 into 60 because it is in the tens position. And similarly, hundreds will have a value of 100 into 60. Let me erase this, not needed. And the thousands column will add up to 60, but the value that it contributes to the sum is going to be 1000 into 60. So if I want to find the complete value, we can easily take a 60 common, and I will be left with 1000 plus 100 plus 10 plus 1, and which is nothing but 1111 into 60. So if we do this, the answer we get the same as 66,660. So to generalize such questions, the answer is write the digits that you would be adding, which will be nothing but all the digits that we use, 1, 2, 3, 4. The number, this is the most crucial one. What does this position says? The number of times. The number of times. The hash means the number of times actually. Any digit, any particular digit appears in any position. And we have found this to be 6 in our case. I hope you get the logic of this. And to add the sum, since it's a 4-digit number, we just multiply it with 1111. This is the answer to it. Let's see if you can get the answer to this question if I make a slight change. What if repetitions were allowed? Now, if repetitions are allowed, the possible ways, how many numbers could I form? I could fill them into 4 ways each position, that is 256 numbers can be formed. So I need to find the sum of all these 256 numbers. Let's see what is going to come in this position. Again, when I add the units column, I would be encountering the digits 1, 2, 3, 4, same out over there, right? But how many times will I encounter them? That is where you should follow this approach. If you put up 1 in the units place, how many possible numbers could be formed? And that the answer is, I could form 4 into 4 into 4, that is 64 possible numbers. And this does not change whether you use how many times does 2 come in the units place, nor does it change how many times does 1 come in the tens place as such, or how many times does any particular digit, let's say 3, come in any particular position. So how many times am I going to get 3 in the hundreds position? I would still be getting 3 in the hundreds position as 64 possible numbers, right? So I would be adding 1, 2, 3 and 4. How many times? 64 times each of them for each column, and the including the positional value, I would have to multiply it with 1, 1, 1, 1. So the answer doesn't, it seems the summation of 1 to 4 is easy. So you should be able to handle it conveniently in this case, right? This will be the answer.